This video is about geometry and specifically about measuring and calculating angles. First, let's look at measuring an existing angle. Here I have the angle ABC. To measure the angle ABC, I'm going to use a protractor. When I look at my protractor, I'll see that I have little crosshairs here where my vertical and horizontal lines meet. When I'm measuring an angle, I always want to line that up exactly with the vertex or the corner of the angle. Now, I'm not quite ready yet. This line here, this horizontal line, should line up with one of the sides of the angle. And I want to be as careful as I could possibly be about lining this up. So before I go to measure the angle, notice that where the horizontal and vertical lines in the protractor meet is where the corner or vertex of my angle is. And I've lined up this horizontal line with one of the sides of my angle. Straighten that out again. Now, when I go to measure with my protractor, I might be uncertain as to which side to start from because there's 0 on this side and there's a 0 on this side as well. Oh, straighten it back up again. But you'll see that the line here at the bottom of my angle, the line BC, looks like it's pointing out towards this 0. So this is the 0 that I should start from. And then I'm going to follow the measurements on my protractor until I get to the next line. Now this line is pointing between 70 and 80. I want to measure that as accurately as I can. It's slightly less than halfway. It's 74 degrees. When I go to write down the size of the angle ABC, I write it by putting 2 straight lines either side of angle ABC. So this means the size of the angle ABC, and in this case it's equal to 74 degrees. Here I have the angle DEF, and I want to measure to see how big it is. So I want to find the size of the angle DEF. Again, I'll take my protractor and I'll line it up so that the crosshairs, or where the vertical and horizontal lines meet, is exactly on the corner of the angle, in this case E. I can call the corner of the angle the vertex. I'm also making sure that this line here, the horizontal line across the bottom of my protractor, lines up perfectly with one of the arms of the angle. So it's covering over the side EF effectively this time. Okay, so again, like we said before, there are 2 zeros, 0 here and 0 here on our protractor. Which one should we go from? Well, this time, the line that I've lined my protractor up with, EF, looks like it's pointing out towards this 0. So I'll count from here. So I'll follow it around on the outside until I get to the other arm of the angle. And this time I can see that the size of my angle is 55 degrees. Just note that you should only use your protractor to find out the size of an angle if the question says use your protractor to measure the angle. This is because in some questions you will need to measure, but in some questions you will need to calculate. Next, let's look at how to draw an angle using the protractor. When we draw an angle correctly using a ruler and protractor, this is called constructing an angle. Here's an example. Construct the angle GHJ. The size of the angle GHJ equals 40 degrees. So there are 2 pieces of information being given to us in this question. The first is the name of the angle, so we know the names to put on the points. And the second is how big the angle is, its size. To do this construction, I will need my ruler and I will need my protractor. To begin with, I'll mark in 2 of my points. I'm going to mark in G and H, just because they're the first 2 letters in the name of the angle. I'm not quite sure where to put J yet, but I'll get to that in a second. I do know that G will be joined to H, so I want to join those 2 things up. Now I know that I should have a third point, J, that will connect to H, but I'm not quite sure where to put it. To make this decision, I'm going to take my protractor and I'm going to make sure that this little crosshairs is lining up with the vertex of the angle, so that second letter H. And I'm also making sure that this horizontal line along the bottom of my protractor lines up absolutely perfectly with this line GH. Now it looks like this line GH is pointing out to this 0 over here, So when I go to measure my 40 degrees, this is the 0 that I'll count from. So 0, 10, 20, 30, 40. Here's my 40 degree mark. I'm going to mark that. Then I'm going to remove my protractor. I'm going to put a dot at that point. That's going to be my point J now. And I'm going to join that back to H. The angle that I've constructed is 40 degrees. Next, let's have a look at calculating an angle. Sometimes I'll be required to figure out how big an angle is without using a protractor. Before we begin to do some examples of this type of question, let's just remind ourselves first of all that a right angle has 90 degrees and that a straight angle has 180 degrees. It's important to remember that even if I split a right angle up into smaller pieces, those pieces will still add up to make 90 degrees. The same is also true of a straight angle. Even if I break it up into smaller parts, those parts will still add up to 180. Here's an example. So in this example, we have a straight line that goes through A, B, and D. Could you tell me what word I could use to describe the points A, B, and D? A, B, and D are collinear, which means that this full angle must be 180 degrees. I know the size of the angle CBD, it's 50, and I want to find the size of the angle ABC. Well, this is easily done. All I have to do is take 50 away from 180, and I get an answer of 130 degrees. I should write my final answer nice and clearly. The angle ABC is 130 degrees. Note, angles that go together, like ABC and CBD in this case, to make a straight angle are called supplementary angles. Here's a second example. First of all, notice how the diagram is put together slightly differently from the previous example. In the previous example, I used the standard notation for naming angles by using 3 letters. So for example, this angle was the angle ABC, and this angle was the angle CBD. In this case, we see a diagram where there are no points marked in, and the angle in this case is just named by a letter. In this case, we want to find the size of the angle E. Now remember, angles that make up a straight angle are called supplementary angles. These 3 angles here make up a 180 degree straight angle, so those 3 angles are supplementary angles. This is important vocabulary and you need to know it. Pause the video for a moment, calculate E yourself, and then check and see if you're correct. Firstly, I added 42 and 45 together to get 87 degrees, and then I subtracted 87 from 180 to get 93 degrees. Again, like before, make sure to write your final answer down nice and clearly, referring to the angle by name. Here we have example 3. In this diagram, we have a straight line. We're told that an angle on the right-hand side is, what size do you think? This notation indicates that it's a right angle. So the right-hand side here is 90 degrees. And we want to find the size of the angle F. Pause the video here for a moment and see if you can calculate the size of the angle F yourself. Do you notice any shortcuts to do this? You might notice that since we have a straight angle and one of the angles is 90, that the other pair of angles on the left-hand side here must also add up to 90 degrees. And this will always be true. If we have a straight angle where one of the angles is 90, the remaining angles must add up to 90. So a shortcut that I could take in this case is to simply say 90, take away the 62 to leave me with the size of the angle F. And in this case, my answer comes out as 28. So the angle F equals 28 degrees. Note that in this example, the 62 and the F make up a right angle of 90 degrees. Angles that make up a right angle in this way are called complementary angles. And again, this is an important piece of vocabulary that you will need to learn. Just another quick reminder here that a full revolution or a full rotation equals 360 degrees. In this question, I want to find the angle G, and I can see that if I put all four of these angles together, I have a full rotation. Notice also that while there is no number value written in for this angle, we do know its size. We know that it's 90 degrees because of the symbol that was filled in. Pause the video here for a moment and see if you can calculate G yourself. When I add up my known angles, I get 210 degrees, and when I subtract this from 360, I'm going to get an angle of 150 degrees. Again, don't forget to conclude nice and clearly by naming the angle that you found. In this case, the angle G is 150 degrees. Here we have one last example. I have a straight line which is broken up into three angles, 50, x degrees, and x degrees. I'd like to work out the value of x. Notice this time that x is not the name of the angle. It's just standing in for the number that is the size of the angle. So I won't use my notation like I did in the previous examples with the straight lines and the angle symbol. I'll just write down what x equals at the end. Before we begin to calculate, take a moment to think, can you remember the name that we give to angles that go together to make up a straight angle? These angles are called supplementary angles. So I know that x and 50 make up 180. Well, if I have one x here and another x here, I've got two x's overall. 2x and 50 equals to 180. What do you think the two x's add up to then? To work that out, I can take the 50 off the 180 degrees, leave me with 130. How could I figure out what 1x was worth then, do you think? I can find 1x by dividing 130 by 2, and so x equals 65. It's easy for me to check if I'm correct. 65 plus 65 plus 50. If I work this out in the calculator, it comes to 180. And that's correct because these are supplementary angles.